Hi everyone! So this video is introducing you to the topic of dimensional analysis, which is basically a sophisticated way to do unit conversions. And I'm going to warn you right now that this is going to be a very important topic for the entire year. So please make sure you take your time while viewing this video, and if you have any questions, please let me know. So as I said, dimensional analysis is a technique for converting between different units. However, once we get familiar with the technique, it also kind of helps to double check that we're doing things correctly so that we don't make any silly mistakes. So the way that dimensional analysis works is it uses something called conversion factors to go from one unit to another. And a conversion factor is simply two equivalent quantities that describe or relate to the same thing. So for example, 1 foot is the same thing as 12 inches, and 1 day is the same thing as 24 hours. They both are describing the exact same thing, just using different units and different numbers. So here I have some metric conversions that I do want you to go ahead and memorize. So the first one is kilo to whatever the base unit is. And the base unit can be grams, it can be liters, it can be meters, any of that type of stuff. So 1 kilo is equal to 1,000 of the base units. So if I have 1 kilometer, that is equal to 1,000 meters. We can also go the opposite way. So 1 base unit is equal to 100 centi, whatever you have. So 1 meter is equal to 100 centimeters. Similarly, 1 base unit is equal to 1,000 milli of whatever you have. So 1 meter is equal to 1,000 millimeters. Okay, so like I said, these are going to be the ones that we use a whole bunch throughout this year, so make sure you memorize these and their meanings. Now, these are some other conversion factors that we're going to use throughout the year, but I do not expect you to memorize these, or at least most of them. So for the upcoming test, don't worry about committing any of these to memory. It's not worth the time. But just focus on those metric units. So I have some examples for distance, mass, energy, pressure, and volume. So those are going to be very helpful when we work through some of the examples. Okay, so the way that dimensional analysis works is it is using something called a factor label table, which I sometimes call the train tracks because they kind of look like them, and helps to organize our work using units and those conversion factors to make sure that we're setting things up correctly. So if we look at this example down below, I am starting with 100 miles, and I want to go ahead and get that into inches. So I use my first conversion factor, which is that vertical column of 1 mile is equal to 5,280 feet. So the conversion factor, they're always stacked right on top of one another. My second conversion factor is that 1 foot is equal to 12 inches. And again, they're stacked right on top of one another. And as you look at this, you see going across the diagonal from the top left to the bottom right, we go from miles to mile, and then foot to feet, so things that mean the same thing, and then we end up with inches. So let's talk about the rules for setting up dimensional analysis. So the first thing is when you read through a problem, always go ahead, underline the given, and then circle what you're trying to find. That will help keep you straight so you don't have any extra information that you're mixing up. Next, you want to place what is given to you in the top left box of the factor label table. So if we go back and look at that previous example, we were given 100 miles. So that is going in the top left box. Next, we're going to arrange the conversion factors that we need so the equivalent quantities are stacked, one right on top of another, and also so the units cancel on the diagonal. Then once we have our table all set up, it's not too bad from there. We're going to multiply across the top, and then we divide by what numbers are on the bottom. Okay, and then finally, you're going to round your answer so that it has the same number of sig figs as the given. So as a reminder, when you multiply and divide, we round by the number of sig figs. Now in this case, we don't care about how many sig figs are in the conversion factors because those are counting numbers, not measurements. So we just go back to the given. Okay, so let's go ahead and try this out with some examples. Okay, so let's go ahead and work through some examples. So how many grams are in 77 kilograms? Okay, so the first thing we want to do is underline our given, which is going to be that 77 kilograms. And then we're going to circle what we were being asked to find, which in this case is the grams. Okay, next thing is I want to go ahead and set up my factor label table. So I draw my horizontal line, and then my given, which is this number right here, it's going to go in my first spot. So I'm going to go ahead and write 77 with the unit kilograms. Okay, units are your friend when it comes to dimensional analysis, so don't be lazy for this step. And I want to go from kilograms to grams. Well, few things. On my diagonal, okay, so on the opposite sides, I need the same unit. So I'm going to have kilograms on the bottom. And I'm going to think, can I relate kilograms to grams? Yes. So I know that 1 kilogram is equal to 1,000 grams. So I'm going to go ahead and put grams up on top. Notice the kilograms cancel out. The only unit I have left is grams, which is what I'm trying to find. So now when it comes to solving this, we're going to go ahead and multiply across the top. So 77 times 1,000 gives me a value of 77,000. And then don't forget your unit, grams. Okay, and I want to think about sig figs. So I have 2 sig figs here. In my answer, I also have 2 sig figs because I have trailing zeros but no decimal points. The zeros don't count. So my first answer is 77 grams. Or sorry, 77,000 grams, much bigger. Your car has a tire pressure of 35 psi. How many millimeters of mercury is that? Okay, so our given is 35 psi, and then we're trying to find millimeters of mercury. So these are units of pressure. Okay, so if I go ahead, I'm going to start to set up my factor label table. So I'm going to draw my horizontal line. And then my given, which is my 35 psi, goes into the first spot, pounds per square inch. Okay, so as a reminder, whatever unit I have up top, I need to have the same thing on the bottom. Okay, so I have PSI on the bottom because I need my units to cancel out. So these are units of pressure, and if I look at those other conversion factors that are in your notes, I see that I have a relationship between millimeters of mercury and PSI. So I see that I have 760 millimeters of mercury. And then for PSI, I have 14.7. Okay, so my units are canceling out. So I'm just left with millimeters of mercury, which is a good thing. Okay, so numbers on top, I multiply. So I'm going to take 35 and I'm going to multiply it by 760. And then we divide by the stuff that's on the bottom. So in this case, it's 14.7. So that gives me an answer of 1,809.52, blah, 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 whole bunch of numbers. Okay, but we need to think about sig figs. So my given, I always go back to my given, has 2 sig figs. We don't care about how many sig figs are in my conversion factors because those are counting numbers. We want to go back to the measurement, which is our given. So I have 2 sig figs here, so I need to round my answer to 2 sig figs. So that ends up being 1,800. Don't forget the zeros, they are important. And then your unit. So millimeters of mercury. Okay. Okay, so thanks for watching, everyone. If you have any questions on this video, please either go back, rewind, and watch it again, or please let me know. I'm happy to help you, but as I said, this is going to be really important. So take the time now to get this under your belt so that when we deal with more chemistry-related conversions in the future, you're ready to go. Otherwise, have a great day, everyone, and I will see you later. Bye.